Hi Chem classes. Today we're going to add on the last little piece from this unit, and that is to find the molecular formula of a compound. So remember that the molecular formula tells us the actual number of atoms of each element in a molecule of the compound. It may be the same as the empirical formula, or it may not be the same as the empirical formula. Let's take a look back at those compounds that we saw in the last video. So for these four compounds, you'll notice that the empirical formulas are all the same, CH2O, but the molecular formulas are different. Each of these is different because each of them has a different structure. This is formaldehyde, here's acetic acid, lactic acid, and glucose. The key here is that the empirical formulas are all the same because despite their different structural differences and molecular formula differences, the ratio of carbon to hydrogen to oxygen in all four of these compounds is the same. 1 carbon, 2 hydrogens, and 1 oxygen. So they all have the same empirical formula, but as you can see, they all have different molecular formulas. And it's not just simply a matter of multiplying by 2 or 3 or 6. It actually results in differences in the structures of the molecules. So what do we need in order to determine a molecular formula? You're going to need to be given the empirical formula, or you're going to have to calculate the empirical formula as you've been doing using either mass data or percent composition. You're also going to need to know the molar mass, the molecular molar mass. Usually this is determined experimentally and would be given to you in the problem. Now let's see what the relationship is between the empirical formulas and the molecular molar masses. Back to our compounds again that we had before. You'll notice that for formaldehyde, its actual molecular formula is CH2O, which is also the empirical formula, and its molar mass is 30. If we multiply our empirical formula by 2 to get acetic acid, C2H4O2, what's going to happen to its molar mass? Well, it's also going to multiply by 2. If I multiply by 3, multiply by 3, right? Multiply by 6, I get a molar mass that is 6 times the original molar mass. So there's a small whole number relationship between the empirical formula and the molecular formula, and they're linked by the molar masses. So the steps in doing these problems are, first, you need to determine the molar mass of the empirical formula. So either being given the empirical formula or calculating it yourself, once you have that empirical formula, you determine the molar mass based on that formula. Then you're going to divide the molecular molar mass, which again would be given to you in the problem, by your empirical molar mass. And this is going to give you that small whole number that you need as your multiple. Lastly, you simply multiply. So whatever the subscripts are in the empirical formula, you multiply all of the subscripts by that small whole number. Let's take a look at one example together. In the last video, you saw me do this problem with percent composition to determine the empirical formula for lactic acid. Now we're going to use the same information but determine the molecular formula. So based on the last problem that we did, we knew that the empirical formula is CH2O. So now calculate for me what the empirical molar mass would be. And you should have gotten 30.03 grams per mole. Now what we need to do is put it into the formula. How many empirical formulas do we have in our molecular formula? So our molecular molar mass, which is given in the problem as 90.08 grams per mole, divided by our empirical molar mass that we just found as 30.03 grams per mole. And we can see here that we get a small whole number of approximately 3. So what do I do with that 3? I find my molecular formula by multiplying all of the subscripts in the empirical formula by that small whole number. So C is a 1 by 3, hydrogen 2 times 3, and oxygen 1 times 3. And that gives me my molecular formula, C3H6O3. Now, to check your work, you can calculate the molar mass of C3H6O3 and make sure that it corresponds to the 90.08 that you were given in the problem. So that's a nice way to double check your work. Okay, that's it, folks. That's all you need to do to find the molecular formula, find the empirical formula, find its mass, the mass of the empirical formula, divide it into the molecular molar mass to get your multiplier, and then multiply all of your subscripts by that small whole number. And that gives you your molecular formula. As usual, time to practice. Any questions or problems, let me know.